So you've done it. You've built the perfect Python application. It's clean, it's powerful, and it's ready to go. But then you hit a wall. A very secure, very offline wall. Let's dive into what happens when your code meets a completely air-gapped environment. Right? This is the fundamental problem. Your beautiful app is completely useless without its dependencies, and your trusty lifeline pip install is just gone. So how in the world do you get all those necessary packages from the wide open internet into one of the most locked down places imaginable? And let's be super clear about what we mean by air-gapped. This isn't just a tough firewall or a tricky proxy server. We are talking about a physical gap. The network is intentionally, physically disconnected from the internet. Think high-security government labs, power plant control systems, or major financial trading floors. For them, security is everything. I mean, on your own machine, life is a breeze, right? You just type pip install requests, and poof, magic happens. But you try that same command on the air-gapped server, you get a faceful of connection errors. It is a tale of two completely different worlds, and our job is to build a bridge between them. You know, if you've ever wrestled with this and thought, man, this is way harder than it should be, well, you're not alone. This comment from a fellow developer on Hacker News just hits the nail on the head. This stuff is genuinely difficult. So, what makes it such a pain? Well, it's a few things. First, you've got to get the right binary wheels for your target system. You can't just throw a Windows wheel onto a Linux server and hope for the best. Then, you have to untangle these massive, complex webs of dependencies. But honestly, the real kicker is often navigating the strict IT security and supply chain compliance rules. That's the big one. And if you're sitting there thinking, well, why don't I just download all of PyPy? Take a good look at this number. The entire Python package index is over 13 terabytes. 13! Trying to move that much data into a secure facility is, well, it's just not going to happen. We need a smarter way. Okay, so we've laid out the problem. Getting our Python packages onto a server with no internet. The good news is there are really two main strategies to get this done. Think of it like a fork in the road. Both paths lead to the same destination, but you've got to choose the one that makes sense for your journey. And here are those two paths. Option 1, you manually bundle up just the specific packages you need for one project at a time. Option 2, you go bigger. You build a permanent local repository inside your network, a private mirror of PyPy for your whole organization. Let's dig into that first path, which we're going to call the manual carry-on. This is your fast, direct, get-it-done approach. It's really perfect for those smaller, one-off projects where building a whole big infrastructure would be total overkill. The best way to think about this is you're packing a suitcase. You're going on a weekend trip. You're not going to pack your entire closet, right? You just pack the outfits you need. Same idea here. We're going to grab just the Python packages our single application needs and nothing more. So how do you actually do it? It's a pretty simple 4-step dance. First, on a machine that does have internet, you generate your standard requirements.txt file. Step 2, you use the pip wheel command to download all of those packages and their dependencies into one folder. Third, you zip up that folder and move it over to the offline system. And finally, you just run pip install, but you point it to that local folder. Done. All right, so that was a suitcase. Now let's check out that other fork in the road. This is the big one. This is about building a robust, long-term solution. We're moving way beyond just packing for a single trip. And the analogy completely shifts here. We are not packing a suitcase anymore. We are building a private library, a permanent, centralized, and secure source of approved packages that every developer in your organization can use, all without ever needing to touch the public internet. Now, even when you decide to build this library, you've still got a few different flavors to choose from. You could build a partial mirror, which only holds a curated set of packages your company has approved, or if you've got the space, you can go for a full mirror. And for the ultimate in control and security, you can use an enterprise-grade repository manager that gives you all the bells and whistles. So what kind of tools are we talking about? Well, for a simple partial mirror, a tool like Python PyPI Mirror can get the job done. If you want a full mirror, Bandersnatch is pretty much the industry standard. But for that full-blown enterprise library with security scanning and access controls, you're looking at platforms like DevPI or commercial big hitters like JFrog Artifactory. This diagram here really gets to the why. Why would you go to all this trouble? because a local repository isn't just a convenience for developers. It is a cornerstone of a secure software supply chain. It's the gatekeeper. It lets you scan, approve, and manage every single piece of code before it ever enters your system, which keeps your security team happy and protects you from attacks. Okay, now listen up, because this is a really, really critical detail. You can build the most amazing private library in the world, but if you forget this step, it's all for nothing. On every single one of your offline servers, you have to edit the pip.conf file and tell it to look at your new internal repository URL. If you don't, pip's just going to try to call out to the internet and fail every single time. All right, we've gone down two very different paths. We've got the lightweight suitcase for a quick trip, and we've got the permanent, heavy-duty library for the long haul. So, the big question is, which one is right for you? This little matrix breaks it all down pretty clearly. The manual, suitcase approach, super easy to set up. You just need pip. But it doesn't scale well if you have lots of projects, and your security control is pretty decentralized. The repository, the library, yeah, it's more complex to set up, but it scales beautifully and gives you powerful, centralized security control for your whole team. And that brings us to the most important point of all. There is no single best answer here. There's no magic bullet. The right choice completely depends on your situation. Are you a one-person team deploying a single app? Or are you part of a huge company with a massive security team and tons of regulations? Your context is everything. And that really leaves us with one final, bigger question to think about. Whether you choose the suitcase or the library, this whole problem forces us to look beyond just our own code. As software supply chains get more and more complex and dangerous, just having a firewall isn't enough anymore. The real question we all have to answer is, what's your strategy for securing the code you depend on?